Welcome back. In this video, we are going to take a look at the basics of how the internet works. So how do your messages and how does data get from point A to point B so fast, so efficiently, so reliability, 99.99999% of the time? So here we go. What you're looking at here is an overview of the major backbone connections of the internet. Now, these aren't all the connections of the internet. These are like the thickest bundle of wires and fiber optic cables that send huge amounts of data across them. Attached to all these wires are more wires that split up into smaller areas. What we're going to do is simplify this picture to talk about how this works. So here's our little simplified picture, which will be easier for us to handle. Now here's what the pieces are. These things are just to represent wires or fiber optic cable connecting pieces, and these circular pieces are called routers. Okay, they route messages from point to point. They're going to be the key pieces that we talk about in this video. Now here's you. Here's your internet service provider, ISP, like maybe TELUS or Shaw, Rogers, whoever you have near you that you pay your 30, 40, 50 bucks a month to. And over here, the other side of the country, or other side of the world, is a web page that you want hosted on this computer, which is called a web server. We're going to take a look at basically how does your message go from you to the web server. So the first thing to know is that every computer or device on the internet basically has an IP address. These IP addresses are made of 4 or 6 numbers. So here's just an example. We'll talk about this in more detail in another video, but your address for this example is 100.150.130.180. Where you're trying to send to is 200.199.100.100. So you know who you're going to, and you know who you're going from. So here we go. Your computer sends a little request that says, hey, I want this web page from coolstuff.com. And that's where the web page is over here. So your message eventually goes to your provider, and the provider is going to help you out with the destination address and tag this onto your message. And so you have a little tiny message saying to this number from this number. Now this goes out onto the backbone of the internet and it eventually reaches a router. And I just call this router A. Router A gets this message and it says, okay, this is going to 200.199.100.100. Do I know how to get to that address? And of course it does. The purpose of a router is to be able to route and handle all this stuff with regards to little messages being sent across the internet. And so it looks in its memory and it goes, yeah, I know how to get that there, and better than that, I know how to get that there really fast. And so it might choose this path. Whoops. It might choose going down to C. Now notice, this might not be the fastest route in terms of distance, but this is the fastest route in terms of time. That's what these routers are usually concerned with, is what's the fastest way time-wise to get it there. Remember, the signals are electricity. Just because this might seem like a more direct line doesn't mean it can't take a longer route. Okay? Sometimes the longest distance will be the fastest route. So it sends it down to C. C gets it. C now says, where's this going? It's going to 200, 199, 100, 100. I know where to get that the fastest way, and it's going to G. And then G says the same thing. M says the same thing. Maybe this is the fastest route to J, to L, to their provider, into the web server, and it gets a little message saying, hey, grab the web page. So it grabs the web page file and starts sending it in pieces back to you. So when it sends it back, it's sending it back to your return IP address here. So it starts sending it back and the same procedure occurs. Okay? And the pieces hop through the internet, taking the fastest route possible. Interesting thing is, let's say in the middle of sending all these pieces of this web page, let's say that this route becomes jammed up. Maybe there's a lot of people watching cats playing the piano on YouTube. This gets all jammed up here, so some pieces made it through. Then this got busy, so the rest of the pieces might take this route and go a different route. That's okay. The pieces all get put back together when they reach your computer. They're all numbered, they get put back in order, and you get your file and you see it. So that's the big overview. Now what we want you to have a little knowledge is how do these routers do it? It's not just magic. There's not some little magic creature that sprinkles some dust and all of a sudden, the routers just magically know where to send these messages. Here's what's going on. The routers all talk to each other, and they're all keeping track some information. They keep track of who they're connected to, and they keep track of the time it takes to get that connection that they're connected to. So for example, this address here is 200.199, 100. Router L will know in only one stop it can get to that address. So router L is going to remember that. It's going to say, okay, in 0.006 seconds, I can get to address 200.199. So it remembers. But then it's talking to router J, and router J says, hey, L, who are you connected to? And L says, I'm connected to 200.199, 100, 100. And I can do that in 0.006 seconds. So J goes, okay, that took an extra 0.03 seconds for us to talk. So that means I can get to 200.199 in 0.008 seconds. And it takes 2 stops. 1, 2. Then J talks to N, and N says, hey, J, who are you connected to? It's keeping track a list of everybody it's learned about from L, also from H, and it gives N that list that has times and IP addresses that it's connected to. And this keeps trickling through the entire network of the system. So you can imagine here, A knows that it can get to address 200.199 because A has talked to B, B has talked to D, D has talked to N, N has talked to J, J has talked to L, and L knows who they're connected to. All the speeds are recorded as the information is shared among the routers. And so what this basically does is it basically gives you an entire network here of computers, or the routers, that all know basically what addresses can they get to, how many, they call them hops, would it take. So this would be 1, 2, 3, 4, 5, 6 hops to get there, and it would know the total time for that particular route. This is nice. Any address you give it now, if you, let's say, wanted to send over to 133.56 something, well, A would know because it's been talking to B, talking to D, talking to N, talking to K. Whoops. So it's going to know the time and the number of hops to get there. It'll also know that it could get there going down here through C, and it would know that time as well. So it knows all the routes, all the times, and it usually picks the fastest time. That's the basics of how these routers work. And what's neat about the system is if you just plunk another router in there, so if I added another router down here, it quickly talks to C and gets all the knowledge C has, which has all the knowledge G has, which has all the knowledge F and M have, etc., etc. So hopefully you're getting the idea of how these things talk to each other. It's very nice. You destroy E, just let's say some rats cut the cable here and cut the cable there. The router very quickly realizes, hey, I can't talk to E anymore, so any information it got from E, it just takes it out of its table. It no longer holds that information from E. It's going to remember the other connections it has. The other nice thing is you take one router out, well, the way they're connected, I can still talk from A to L, or a lot of other combinations. You would have to take out a lot of routers to destroy this network, right, and make it so it can't talk. So, a little overview here. The main job of the routers, keep track of what IP addresses it can directly connect to. Know how quick each connection is, okay, in terms of seconds. Communicate with the other routers to find out which IP addresses they can connect to and get to. Move the packet in the best direction possible. And the packet, that's just a little piece of your message. So if you have a video file going over, that could be millions of packets. Every little packet gets sent off individually, right, in the best direction, and then put together when it reaches the destination. And then another thing I didn't mention was they confirm and send confirmations that packets have been sent and received properly. So another big job is when A sends something off to B, when B gets it, and it has it, B will send a little message back saying, got it. A knows its, A knows its job is done. If it gets a message back going, you know what? I didn't get that, it didn't work, or there was an error, A can resend the information. So it's a very nice system for reliability and for flexibility. That's the basics. What goes on here. We're also going to link you to a little video that shows you this again with much nicer animations. Thanks for watching.